So let's say that these are the coefficients from a polynomial that is of degree 5, and these are a couple of the given roots. So I would recommend throwing in the easier numbers first into our synthetic division algorithm. Leave that there. So that'll be 15, and that'll be 3,0,0,1/5. That'll be 95 rather, 95. And this will be 19, 0, 0, 140, 28, and then the remainder is going to be 0. So that's a 95 there. There it is. And now let's continue with synthetic division. And this is going to be my new remainder. And now we're going to plug this guy in here. We have the negative square root 21 over 3i. And let's see what numbers we would get. So let's drop the 15. And then on a calculator, if you multiply these ones here, or if you just take 15 and divide it by the negative 3, either way, you're going to get negative 5 square root 21 with an I. And if I add nothing to it, it'll remain negative 5 square root 21i. And so now what I have to do here on my green scratch paper is take negative square root 21 over 3i and times it by negative 5, negative 5 square root 21i. I got to times it by this number. Let's see. So a negative times that negative is going to be a positive. And then 5 is just going to be 5. Square root 21 is just 21. And then the bottom there is a 3. And then I times I is I squared. And now here on a calculator, that's going to be 35. But you know what? If I'm going to go calculator here, I might as well have gone calculator there and calculator there, which is why we recommend that students just use their devices to get that one times that one. And we know that I times I is I squared. And I squared is negative 1. So it turns a 35 into a negative. So here, this would have been negative 35. And that gives us back 60. When you add these numbers, 95 plus a negative 35 is 60. Now go 60 times this here, again on calculators, and just attach the I for yourself. Like in a calculator, I'm not going to type in I. I'll just type in the negative fraction times 60. And it'll say negative 20 square root 21. And then I'll just attach the I for myself. Plus 0. It'll stay the same number. And now back here on some scratch work, I have negative square root 21 over 3i times negative 20 square root 21i. Calculator here, calculator there. That'll be a positive 20 times 21 over 3 with an I squared because it's I times I. And it looks like the calculator would say 140 with an I squared, but that makes it negative 140. So this will be negative 140 and then 0. And then you might be like, okay, we're out of roots to experiment with, but not quite. Because remember, if this is one of the roots, then so is its conjugate. And now we can take the conjugate and we can throw it in here. And usually when you throw in the conjugate, it works out much nicer. So that's the conjugate of this guy. And I put it there. And now let's continue this process. You see here, this will be 5 square root 21i, and that gives you 0. 0 times that is 0, plus 60 is 60. 60 times that is going to be positive 20 square root 21i, which creates a remainder of 0. And now we're pretty much done. What we can do here is we can build this polynomial. See, that's your constant. And this is x, and this is x squared. X squared. So we get 15x squared plus 0x plus 60 equals 0. I don't have to write the middle piece, and I can actually reduce by 15. When you reduce by 15, you're just dividing both sides by 15. 0 divided by 15 is still 0. And then subtract the 4. And then when you square root, you get plus or minus the square root of negative 4, which is plus or minus the square root of negative 1 times square root of 4, which is plus or minus I times 2, which is plus or minus 2i. So the missing answers were these guys here. So this one had 5 zeros, or 5 roots. The 2 that are given, the conjugate that we discovered, and the 2 that we really discovered for ourselves. So we have 1, 2, 3, 4, 5 roots for the original fifth degree polynomial.